Tomorrow we're going to be going to point 660 to measure ablation, and we'll be going along this path all the way up here to point 660, and we're going to be measuring the ablation by putting bamboo sticks in different types of materials, so darker snow, water, and just plain ice, and we're going to see which one reflects more and melts more. And tomorrow we're just going to be placing the bamboo sticks, and later we'll come back and see how our results are.
The last car, which was kind of dumb, but it should have been me or Casper.
Yeah. Arrived at point 660, and behind us you can see the moraines. It's like rocks and stones and sediments that the ice has pushed forward.
So we have a lot of these bamboo sticks here that we're going to be placing in the snow by drilling, and later we'll come back and see how much the ice or snow has melted around them. And I just want to show you something about these rocks here. These were both found in the moraine. And this one, as you can see, is quite jagged, which means that it has only been inside the ice for a very short amount of time. And this one has been in there for a long time because it's really round, because the ice actually chips off parts of the rock. So it's just an interesting way to see how long the rocks have been inside this big ice sheet here. And that's just a little bit about the moraine we're standing on.
Yep.
We are now drilling a hole in the whitest snow on the glacier. We also drill into the dark snow and a small stream to compare the albedo's effect on the ablation or melting of the surrounding materials.
The data we collected included infrared scanning of the materials to get a measurement of the temperature, as well as taking a measurement of the amount of light reflecting of these materials.
It was important to make sure that the scanner was always the same distance from the surface to get an accurate reading. That ensured that we had constant data. Return to point 660 soon to take a measurement on the melted areas, and we can't wait to share results with you.
Our hypothesis is that the ablation will be affected by the albedo of each material. We expect that the higher the albedo or the whiter the snow, the less it will melt. This is based on our knowledge of the fact that darker materials absorb more light energy, which heats them.
We have now returned to point 660 to collect our data, and there has now been a week since we were here last time.
Here we are measuring the height of the melted snow and ice. The difference between the original 1 meter depth and the current depth indicated the height of melt around the bamboo stick. You can see that the dark snow has melted significantly since our last visit. measured the light intensity, each material decreased in albedo or got darker, meaning it melted closer to the dark ground below. This will accelerate the melting process.
To our surprise, although the albedo of the stream was the lowest of the three, it melted less than the dark snow. This could be because the water running in the stream over the ice was already melted, compressing the ice and warming it.
The snow was crystallized and filled with pockets of air while the ice was compact and smooth. This means that the volume the snow melted was actually less than the ice. Additionally, the snowbanks surrounding the stream melted, reducing the amount the ice could reflect from the bright snow. All these factors contributed to the ice melt being less than we had expected. We did, however, discover that our hypothesis that albedo and temperature are related was correct because the difference in the albedos we measured the first and last day correlate to the height of the ice melt.
Over the summer, the ice will melt 6 meters on average. The winter brings replenishing snow. But if evaporation and runoff amounts exceed the accumulation of snow, the result is net loss of ice.